we discussed in detail about the regression, about the equations of regression analysis. We derived it, and we also discussed on the trend variations, on increase or decrease of trend variations, and we also discussed on how the coefficient of correlation it varies with regarding to uh, uh, increasing and decreasing characteristics, and we also discussed the time series model, casual series model. So the question here is, if in regression, what's the equation for regression correlation coefficient? What is, if the correlation coefficient is 1, then what will be the regression equation? So, suppose y is equal to a plus b t. So, here correlation coefficient is equal to 1. Now, so let's make this one. Okay, so coefficient of correlation, so that tells us how much percent data falls on the line of the graph. We made a graph plotted in last class. Falls in the line of the graph in welcome to the 11th live session of Principles of Industrial Engineering. So today we'll be discussing on uh, forecasting, a little bit again on the time series and casual series model, regression analysis, quality characteristics, and we will be further discussing on also the control attributes for variables and control charts for variables and attributes. Um, we'll also be discussing on the variation, different types of charts, normal, abnormal variations, upper control limit, lower control limit, mean control charts, and mean control charts range, uh, all those topics. So let's start with the session. So the first question is, the linear regression equation for the correlation coefficient is which equation? So first we will discuss what is the coefficient of correlation. What happens when the coefficient of correlation becomes 1? Coefficient of correlation, it tells us how much percentage of data falls on the line of the graph plotted in trend variation. So what happens here is, suppose this is y, x, we will assume this is the correlation coefficient rxy is equal to minus. Now this is for the decreasing trend. Now for the increasing trend, we will find out how much of the slope falls on the trend line, trend variation line. This is rxy is equal to 1. So regression analysis is used where we have a trend, like increasing trend or decreasing trend. Increasing trend means the forecast value is greater than demand, and decreasing trend means the forecast value is less than demand. When trend is concerned, always regression analysis is used. So then according to this, so we know that this is the straight line equation, y is equal to mx plus c. So here the slope y is equal to mx plus c, or we can also say, so here this is equal to 1. The slope is always 1. So the correct answer is y is equal to a plus x. So the next question is, the quality technique both the top to bottom people are responsible in is inspection quality control, operator quality control, foreman quality control, total quality control. Now, how the quality has been controlled over a period of time, what different approaches are developed over a period of time, like the quality operator quality control, foreman quality control, statistical quality control, total quality control organization, design of experiments, TQM. So when the inspection based approach is considered, here whatever is being produced after manufacturing, it is checked, and if it is as per the specification or as per the requirement, then it is accepted or it is rejected. And for the quality control approach, the process of making the goods and services is controlled. So the process is controlled through the proper control of the materials, process parameters, procedures. And it believes that if the process is controlled, the product being produced by the process will also be of the good quality. So the quality products can be produced through this process control. So in this question, the correct answer is the total quality control. Now, here the process of making the goods and services is controlled. That means here, so here the process is controlled through the proper control of the materials, process parameters, procedures, etc. Now, it believes that if the process is controlled, the product being produced by the process will also be of the good quality. And if we take example of some other quality control approaches like inspection quality control, here uh, whatever is being produced after manufacturing, it is checked, and if it is as per the specification or as per the requirement, it is accepted or rejected. Okay. So moving on to the next question. The control chart for attributes is which of the following? Okay, so we will again discuss little bit on the control chart for attribute and variables. In this question, we will discuss on the control chart of the attributes. Now, this is control chart of our attribute. This is a uh, it is of C chart, P chart, and P chart. C chart is number of non-conformities in a product. Now, non-conformity means quality characteristic not matching with specification or standard. It is also called as defect. P chart means properties of non-conforming units in samples. NP chart means number of non-conforming units in a lot. Now, non-conforming non-conforming units means quality characteristic not matching with specification or standard. Also called as defect. Now, according to the question, the control chart for attributes is X chart, X bar, R bar, P chart, A chart. The correct option is P chart. Now, X bar and R chart, these are the quality control charts based for the variables. This is for control chart for the attributes. These are variables. Okay. So the next question. Customer dissatisfaction and airline reasons are given below. Identify reasons which are 80% of the problem customer dissatisfaction are caused by. So, to analyze this, we will first draw a Pareto chart of reasons. Now, Pareto chart of reasons consists of the count of customer dissatisfaction and the reasons that is on y-axis. Y-axis consists of percentage and count of customer dissatisfaction, and x-axis consists of the reasons, customer dissatisfaction reasons. So, Pareto chart of reasons. Now, according to the question, we have count of customer dissatisfaction. This is percent. Now, this is reasons. Let's distribute it into divisions. 20 divisions is 20, 40, 60, 80, 100. Same on this 20, 40, 60, 80, 100. Now, according to the count, we will arrange. So, the delay in arrival is 50. So, delay in of attendant 30. Next is quality of meals and lost baggage, which are each 10-10. Lost baggage and quality of meals. Now, according to this, now we will draw Now we will draw the Pareto chart of reasons. So the count of customer dissatisfaction is 50. So the percentage is 50. So the cumulative percentage is 50%. Count of customer dissatisfaction when it is 50, percentages 50, cumulative percentages 50. Next, when the count of customer dissatisfaction is 30, percentage is 30. Now cumulative percentage is now 80. So we draw a line from here to here. Okay. Next, when the count of percentage customer dissatisfaction is 10, the percentage is 10. Now cumulative is 90. Now we draw from here a straight line to this middle. Okay. Now, when the customer satisfaction again 10, percentage is 10, cumulative is 100. Now, we draw a straight line to this middle. It will be so this is the way of drawing a Pareto chart of reasons. So, to identify the reasons which are the 80% of the problem are caused by. So here the 80% of the problems are caused by 2 and 4, that is delay in arrival and attitude of attendant. These two are the reason of the 80% of the problem. Okay, so next question. Less variation delta range in statistical quality control of a problem helps in which of the following? So, when the variation is less, it reduces the wastage. Further, it reduces the cost because we will be reducing the waste. The waste. So, next, further, we will be increasing productivity and the number of rejections will be reduced. Thus, variation in quality characteristic is reduced. Now, when things will be manufactured with a very less variation, this will improve the quality of the products. That is its functionality features. Functionality features in turn will help in improving the competitiveness of the product. So, as per this discussion, all of the points, these all are included in a statistical control of a problem when there is less variation. Okay, so now the next question. The degree to which the product conforms to the specification is. Now, last time we learned about the quality characteristics where there were 9 quality characteristics. Uh, so, those were performance, feature, conformance, reliability, durability, service after the sale, response, aesthetics, and lastly reputation. So, conformance is about that how good a product or service is close to the specification or quality which has been committed with respect to the specifications or standard, how good or how close a product is. So, conformance means with respect to standard, how. So these are the 9 independent parameters related with quality. So conformance means with respect to standard or specifications, how good or how close a product is. Standard or specifications, how good or close a product is. So the degree to which the product conforms to specification is quality of conformance. Also, here we can discuss what is the design. Design means quality of design, quality of performance, quality of service. So, quality of services, service after sale for regular maintenance that is available. Quality of performance is the first quality when a product is delivered to the customer, how good it performs during the use. That is the primary function. And quality of design means is the feature. Okay, so moving to the next question. The actual and forecast demands of product X is 90 and 100. The tracking signal of the value is which of the following? Now, we discussed about tracking signal last week also. Tracking signal is cumulative error by absolute deviation. Now the cumulative error here is minus 10 and absolute deviation here is 10. This means the answer is minus 1. Also, if anyone has forgotten how to calculate the tracking signal, and you can refer the last question of last class, where I have discussed in elaborately the regarding the tracking signal. Okay, this is the cumulative error, that is we find out by di minus fi minus by MAD, mean absolute deviation of that particular uh, data. Okay, so the next question. The actual and forecast demand for product A is as follows. Here we are given the actual and forecast demand for 3 periods. So we need to find out the mean squared error value. Now, mean squared error MSE is equal to I is equal to 1 cumulative of I is equal to 1 by di minus fi whole square by n. Now here we need to find out the cumulative error of each period. So that will be 10 minus 8 whole square plus 4 minus 2 whole square plus 8 minus 2 6 whole square by 3. This will be 4 plus 4 plus 4 by 3, 12 by 3 is equal to 4. The correct answer is 4. So next question, the seasonality index for a product is 0.3 and the average demand for each season is 60. Then the forecast seasonality is, okay, so this is a different question. So here we are being asked the forecast seasonality, that is seasonality index into average demand for each season. So we had discussed about a seasonal variation in our discussion during forecast. Seasonal variation as in where there is demand for a particular product during a particular there is short-term regular variation in a given season. So in that case, like I had given the example of demand of woolen clothes and a particular time of a year or particular season. So that is the seasonal variation. So here the seasonality index is 0.3 into average demand for each season is 60. This will be 80. The correct answer is 80. Okay, so the next question. Control limits in process control chart is defined as which of the following? Limits decide the customers driven by the natural or inherent variability of process, statistical limits. Now, control limits, these variations can be random. That means about random means about the central or mean value. The points are falling randomly here and there. There is no systematic trend or pattern. So when the random variation in the characteristic occur, this is called the natural variation, where output of the process is also common variability or the chance variation occurring due to the chance causes. So control limits in process chart is driven by the natural variability of the process. Now we'll understand this in the detail. Variations can be random. Random means about the central or mean value. The points are falling randomly here and there is no systematic trend or pattern. So when when the random variation in the characteristic occur, this is called natural variation. So in this, in which output of the process also called a common variability or the chance variation occurring due to the chance causes. Okay, so the next question. In control chart, data points lie beyond the upper control limit and lower control limit are called as which of the following? Now, we have this mean, we have this upper control limit, we have this lower control limit. Now, these are some points. Now, this is normal variation due to chance. These are beyond the upper control limit and lower control limit. We have abnormal variation due to assignable sources. Okay, the graph was between quality characteristic now. Here also same, beyond the lower control limit we have abnormal variation due to assignable sources. Now here, so according to this, data points which lie beyond the upper control and lower control limit, the correct answer is abnormal variation due to assignable causes. Okay, so the next question, a control chart used for monitoring attribute many number of non-conforming units in a sample is. So as we discussed in this question, we had for attribute C chart number of non-conformities in a product, P chart properties of non-conforming sample, and NP chart is number of non-conforming units in a lot or sample. Many number of, so here the question is asked is many number of non-conforming units in a sample. So when it is many number of non-conforming units in a sample, the correct answer is NP chart. So the next question, in a mean control chart for variable, upper control and lower control limit is a function of which of the following? Now upper control limit is equal to x bar plus a2 r bar, lower control limit is equal to x bar minus a2 r bar. Now here r bar is equal to average of range value identified from the different samples which have been taken from the lot. X bar is equal to average of the mean values identified from the different samples, and A2 is equal to coefficient which is identified using the number of items in a sample or sample size. So according to this, the correct option is A, x bar plus a2 r bar and x bar minus a2 r bar. This is subscript. This is all subscript. Now the next question. In a mean control chart, the mean of 5 samples are as given. So we will write the mean of the 5 samples. X1 bar is equal to 10.515, x2 bar is equal to 10.2, x3 bar is equal to 10.11, x4 bar is equal to 10.34. Now for a mean control chart, sigma
we have sigma is equal to 0.03. So for this, the first I'll write the formula. Sigma x bar is equal to sigma by root over of n. This becomes, now here sigma is equal to 0.03, n is equal to 9, and x bar or sample mean is equal to x1 bar plus x2 bar plus x3 bar plus x4 bar by 4 is equal to 10.15 plus 10.2 plus 10.11 plus 10.34 by 4 is equal to 10.2. So this is sigma by root over of n. Now the z is equal to 3, since it is given 3 sigma mean. Now here sigma is equal to process standard deviation n is equal to sample size sigma x is equal to standard deviation of the distribution of sample. Z is equal to standard normal deviate. Now we will solve this question. Sigma x bar is equal to sigma by root over of n is equal to sigma is 0.03 by root over of n. Sigma, we know from here, it is given the question, n is 9. Since it is given under 9 observations, sigma 0 is equal to, this becomes 0.01. Now z is equal to 3 sigma mean. Now we will find out the upper control limit, which is x bar plus z sigma x bar. Lower control limit is equal to x bar minus z sigma x bar. This is 10.2 plus 3 into 0.01, which we found out just now. Z is equal to 3 given, x bar we took this value is equal to 10.23. This is 10.2 minus 3 into 0.01 is equal to 10.17 answer. So the correct option is 10.23 and 10.17. Now the next question. In a process, the ranges of the factor are, now this is a mean control chart range. Question of mean control charts range. Now here we have been given the range of the factors like the R1, 1.5, R2, 1.3, R3, 1.2, R4, 1.8, R5, 1.6. Now first we will find out R bar. R bar is equal to R1 plus R2 plus R3 plus R4 plus R5 by 5. This becomes 1.5 plus 1.3 plus 1.2 plus 1.8 plus 1.6 by 5. This becomes 7.4 by 5 is equal to 1.48. Now the subgroup size is given 5. and it is asking the possible standard deviation. Given D2 is equal to 2.326, A2 is equal to 0.577. Now standard deviation for the mean control chart ranges is R bar by D2. This is 1.48 by 2.326 is equal to 0.636. Now we have a table from table. When sample size is 5. This data we get from table when the sample size is 5. So with this we find out the standard deviation, which is 0.063. Correct option is A. Okay, this was the question for mean control chart range. Previous question we solved about the mean control chart sigma. Okay, so the next question, higher value of P bar indicates which of the following? So higher value of P bar, this means intervention of management is needed. So what happens in this case is, value of P bar higher means fraction of defective items. P bar value higher means fraction of the defective items is increasing. This means quality of the things or products or services which are being provided is deteriorating. Deteriorating. That so this means management now needs the intervention in form of expertise, in form of better machinery or better procedures. So major intervention is needed when it happens that the average P bar value is high, and when it is reduced, indicating that the average fraction of the defective item is decreasing. So that is one inference, and it indicates the process capability. Central line value, that is the P bar value, indicates the process capability, how capable of processes. Now when there is a lower value of P bar, it will indicate the better capability of the process, showing the lesser fraction of the non-conformity items, so that will be indicating the process can be used to produce large number of goods without producing many non-conformable items. So this is also one type of interference when the central line value indicates the kind of fractions which will be their average fraction of the non-conforming items and the process capability, and if the P value is high, then it needs the intervention of the management. On the other hand, if there is a process giving the P value randomly here and there, that means some non-random pattern is not there, but random pattern is being indicated, then that will be showing that the process is under control, but the movement of the points start falling beyond the control limits. Then it will suggest that for the same process which was doing well, producing fewer non-conformity items, certainly it has started to produce the thing so that it has started to fall beyond the control limits. That suggests there is some problem in the manpower. So if the points in the P chart are falling beyond the control limits, then the intervention with regard to manpower is needed, and if the process average or center line value is shifting from its position towards the higher side, then the intervention of the management is needed, which may be in form of better machinery, procedures, manpower, skill to reduce the proportion of the non-conforming item. Next, the gap between upper and lower limit in a control chart will be wide if the correct option is few number of items selected in a sample. So, this what happens here is we have very few number of units or products in a sample. This affects few units or products in a sample affects the kind of control charts. Which will be developed. So there has to be an up and more suitable number of units which are selected in a sample. Suppose let's take 4. We say for instead of 4, if we selected 12 or 10 units in a sample, then control charts will be very tight. It will be very sensitive, and control limits, upper control limits and lower control limits will be very close to the mean value. Then on the other hand, if we make the control charts very sensitive, in addition to plotting the controls, these average values of the characteristics, we also plot the upper and lower control limits. So we have a large number of units or products in a sample, so these limits will be closer to the average, which will make the control chart very sensitive, or there will be a fluctuation or variation in the quality characteristics. So this will be in turn leading to the rejection or out of control situation. So apart from this, making the control charts very sensitive, it will also increase the kind of efforts to be made for quantification of the quality characteristics for many items which have been selected in a sample. So there can be a lot of variation when fewer samples are selected. So the control limits may be very wide. That may lead to a situation where the things being produced may not be within the acceptable level. So these are some of the various scenarios which can happen when the limit between a upper control limit and lower control limit is very wide or very narrow in a control chart. Okay, so next question is, following activity is not an integral part of method study. Now, it is said that method study, so we know that work study includes two broad techniques, method study and work measurement. Work study includes method study and work measurement. Now, work measurement, it focuses on the quantification of the time using various techniques like work sampling, standard data method, predetermined time motion study or time study. Now, now work Now, work measurement is used for two purposes. One is quantification of the presence of ineffective time. So, once the ineffective time is identified in the aspects of procedures, then that is eliminated, and then the another purpose of work measurement is to quantify the time for doing a job using the best possible method so that standard time for doing the job can be set. So these are the two purposes used for
work measurement, setting the standard time and identification of the ineffective time. Purpose is setting standard time, identification of the ineffective time, and this is realized through the work sampling, or like different these techniques. This is realized through this technique. So on the other hand, method study, this focuses on the job for improving the method of doing a job, so that all redundant things, unnecessary things can be eliminated, efforts of the worker can be reduced, method is developed in such a way that the job can be completed in a minimum possible time. So here it, so as per the discussion, redundant jobs can be eliminated, unnecessary workers effort can be eliminated, and desired job can be completed in minimum possible time. But so time needed for various activities can be quantified in work measurement. This is a work measurement meant technique. So So basically, in method study, it records the observation, does the critical analysis, develops new method for doing the job, then it defines the method developed for doing the job using the improved method, and this is installed, this method is followed and maintained so that people do not have a tendency to go back to the previous method. Thus, these were the two approaches of the work study, method study and work measurement. Method study focuses on improving the existing way of doing the things or coming up with newer methods for improved and effective way of doing things so that jobs can be completed in minimum possible time. It focuses on reducing the added work, elimination of the ineffective time, while work measurement helps in identification of the ineffective time and setting the time standard which can be used for developing several other tasks such as wages, incentive plans, etc. Okay, so the last question. The following chart records the movements in the work study. Okay, this we know very nicely. Control chart we already discussed now. Operation process chart, flow process chart, we Gantt chart. We all have discussed in the previous. So here the correct option is the flow process chart. Work study involves the flow process chart as we discussed in the previous question. Work study involves the flow process chart. Okay, so these were the discussions today. So if any questions are there, we can discuss further. You can also ask your questions in the announcement tab. We will address that. Okay, so if there are no further questions, we will end the session. Thank you all for attending the session. We'll meet again next week. If there are any questions, you can still ask, you can discuss.
Okay, so it was very nice to have the session today. Thank you all for attending the session. Let's meet again next time. Thank you.